Hey everyone, welcome to episode 3 of Distributed Systems 101 series. Here in this episode, we will discuss multi-leader replication. So, if you are following this series, you must be knowing that we covered single leader replication in our previous series, in our previous episode. So, I'll just quickly do a recap of single leader replication and then we will gonna hop on multi-leader replication. Okay, perfect. So, let me quickly draw this up. So, single leader replication. What we had is that we had a system. Okay. Now, this system was having multiple replica machines. So, let's call this a system. This system had multiple replica machines. One of the replica machine was a leader, right? Let's call it a leader, and the rest of the replica machines were followers. Let's call them followers. So, let's call them F1, F2, and F3. So, one leader and rest of the replica machines were followers. Now, what used to happen is that we had a client, and the client can send requests to this system. Now, client can send two types of requests. It can send either a read request or a write request, right? So, if a client sends a read request, then it can be directed to any of the replicas. It can be directed to leader as well, or it can be directed to follower as well. It is completely okay. Followers can also take up the read requests in the single leader replication scheme. But for the write requests, it was mandatory for the write request to be taken up by the leader, right? And since there is only one leader in single leader replication scheme, there is only one machine which can take up the write request, and this machine used to further direct this request to other followers so that they can also update their data. So basically, if in a write request some of the data items were updated, then the leader used to perform that, but it will also use to forward this request to rest of the follower machine so that they can also update their data items, and there should not be any data inconsistency within the system. To perform that, this was the entire process which was happening. This is what we covered in single leader replication scheme in our previous episode. Now, the issue is, here is the single dependency problem. What is that? Suppose if this leader machine goes down. So if this leader machine goes down, then the client will not be able to send any write request to the system. Although it can read from it, but user cannot send a write request, or a client cannot send the write request, because this is a single leader replication scheme and we have only one leader. So we have only one leader, and since this leader got failed or got dropped off, the write request will not be processed. So if a client sends the write request, it will not be processed, and since this is a replicated machine, or we have a lot of servers, but still if the leader goes down, the entire system goes down. It will not able to function properly, and this is the problem we are trying to solve through multi-leader replication. Great. Now let's understand multi-leader replication. So I'll clear this screen up. I'm gonna write multi-leader replication. Now, as the name suggests, in multi-leader replication, we can have more than one leaders. So let me draw that up again. We again have a system, right? We again have a system, but in this case, irrespective of single leader replication scheme, we can have more than one leader. So suppose that we have two leaders, name them L1 and L2. Rest of the replica machines are followers. So let's have two replica machines as well. Name them F1 and F2. Okay, name them F1, and one of the replica machine is F2. Now, since we have two leader, what a client can do is that if this is a client can send its write request to either of the leader machine. So leader 1 can also take up the write request and leader 2 can also take up the write request. This is a kind of flexibility we got using the multi-leader replication scheme. But here is a catch. So suppose if our write request went to leader 1. Suppose our write request went to leader 1, then what will happen is that this leader will perform the processing, but along with that, this leader will also forward this request to all the replicas, including the second leader as well, right? So the write request from the client was sent to L1 and then L1 forwarded this request to the followers and the leaders as well, so that they can also perform the same operation and there shouldn't be any data inconsistency in the system. Now, this means that here at this point of time, L2 acted as a follower, right? L2 acted as a follower for L1, right? So this is one thing that can happen is that sometimes leaders can act as a followers for other leader because they also have to update the data item, right? They also have to keep their data consistent with the write request, incoming write request, right? And same thing could happen vice versa as well. If this write request would have gone to L2 instead of L1, right? If the write request have gone to L2 instead of L1, then L2 would have forwarded this write request to F1, F2 and L1, and in that case L1 would have acted as a follower to L2. I think this makes sense. Okay, and yeah, another thing I want to cover is that in previously in the single leader application we saw that we had a single point of failure, but here we will not have any single point of failure. So if suppose in some cases L1 went down due to some unfortunate reasons, in that case our entire system will not go down, right? And our entire system will not go down, it will still be in an active state and L2 will be able to take the write request in that case. So if L1 goes down, then all the write requests which were getting forwarded to L1, instead of getting forwarded to L1, it will gonna be forwarded to L2 and the system will still be active in an active state. So this is one thing which this is one benefit which we get using the multi-leader replication scheme, that since we have more than one leaders, we reduce the single dependency problem. If one leader goes down, second leader can actively accept the incoming write requests from the client. Now let's quickly understand the use cases for multiple multi-leader replication schemes. So I'll discuss my first use case here, that is when we have systems with multiple data centers. So let's start with the let's start with the initial approach. I'm gonna clear this up, and yeah, let's discuss our first use case. So this is the use case one where we have multiple data centers, right? Let's write it down. Multiple data centers. So initially, suppose I'm creating a startup, and I am a US based startup, right? I am a US based startup and I have one data center which is obviously based on US. So let's draw it up. We have one data center which is US based, right? Basically in the Americas region. Now this has a leader and rest of them are followers. Okay, now let's write it down here. We have leader, again we'll mark it up as L1. We have followers, right? Mark it up as F1, F2 and F3. So this system has one leader and three followers. Now what can happen is that we can have a we can have a client, right? The client can send the request. Again, in a very similar way we discussed earlier, the client will send the request, and if it is a write request, it will be sent to a leader, and then the leader will forward this request to rest of the followers. But if the client is in US, then it makes sense. But what if we got a client, right? What if we got a client who is maybe based in an APAC region, right? Maybe he is querying from India. Then in that case, that client will also have to send that write request to this leader, right? The client will have to send his request all the way from India to US region to this leader to get it processed. This can cause some latency issues, right? It can take a lot of time for this client to send the request to this system and get the response back. So now in order to resolve that, what we will do is that we will have multiple data centers. But again, we are currently using a single replication scheme, single leader replication scheme. We have not moved to multi-leader. We'll move to that afterwards. So let's clear this up again. Now I'll make some room. I'm gonna delete this up as well. Yeah, great. So this time we will have multiple data centers. Okay, so let's have two data centers here. I'm gonna draw two data centers very quickly. Right. Let this data center be US based and let this data center be in APAC region, maybe in India. But this entire system has only one leader. So suppose this is one leader and rest of them were the followers. Okay. Rest of them were followers. Right. 3 followers here. I'm gonna add 4 followers here as well. Right. So this is a single leader replication scheme. That's why if if a client is based in US, then it is okay. He or she can send the data to the US based data center, to the leader which is present in the US based data center. So they can send their request. Suppose there was a write request, they can send their write request to the US based data center. But if we have a client which was suppose based in India, then again, since this is a single leader replication scheme, the client has to send its write request all the way to the leader, because that's what we read in the single leader replication scheme, right? The write request is forwarded to the leader and then the leader forwards this to all the other replica machines. So this and since there is only one leader in this entire system which is present in a data center based in US region, the client is bound to send this request to L1, which is based in the US data center. Now you're seeing that like even though client has a data center which is near to them, right, in the APAC India region, but still they are not able to send their request to this data center. They are bound to send their request to the leader L1 which is present in the US data center. Now this is an issue with the single leader replication scheme. To avoid that, what we can do is that we can simply introduce one more leader, name it L2 in APAC region. Now, since we have a new leader appointed in an APAC data center present in the APAC region, now the client which is present in India does not need any more to send their write request to the leader present in the US data center. What they can do instead, they can simply send their write request all the way to the leader present in the APAC or in India region, and this will reduce the latency. Right? The latency issue which the client was facing earlier, they don't need to face that latency issue again here. And since the leader is like once the leader gets the data, they can forward this data to rest of the machines. Now another interesting thing to see here is that once the leader gets the write request from the client, the leader forward the request to all the follower present in the current machine, but it will not gonna send this request to all the replicas present in another data center. Instead of that, the leader will simply send this data to the leader present in the another data center, right? So the leader sent the request to another leader which was present in the different data center, and then the responsibility, it is responsibility of this leader to forward that request to rest of its follower present in that data center. And this rule applies to all the other data centers as well. So suppose if we had more than 2 data centers, suppose we have 3 to 4 data centers, in that case as well, the leader will, this particular leader L2 will gonna forward this request to those leaders present in those different data centers, and then this is the responsibility of those leader to forward that request to rest of the follower present in that data centers in their respective data center. And in this way, the entire service or the entire system is consistent or remains consistent. Now let's understand the second use case. So in the previous use case, we talked about multiple data center. In the second use case, we will talk about Google Calendar use case. So I'm gonna quickly write it down. Use case 2. What we will gonna see is that we're gonna see what how this multi-leader replication scheme can be used in Google Calendar or any application similar to this. So the idea is that while using Google Calendar, you can have your ID logged into multiple devices, and that is pretty normal. I have my ID logged into my my laptop, my tab, and my phone as well. So suppose I have 2 phones, one tab, and a laptop. So let me quickly draw these up. So suppose me being a user, I have my ID logged into multiple devices. Let one of them be a laptop, right? Again, this laptop will have its own local storage, right? It will has its own conflict resolution module, right? And suppose we have a calendar app here, right? Call it calendar app. Now, similarly, we have some other devices as well. So suppose another device which I will be talking about is a tab. Suppose I have a tab as well here, right? And again, the similar stuff, tab will have their own local storage, right? They have their own conflict resolution module, and they have their own calendar app. Now, don't worry about conflict resolution module right now. We're gonna cover that in a separate lecture because it's a big topic, that how conflict resolution happens when multiple leaders are in the picture. Just for the time being, just assume that this is a module which resolves conflict when there is a conflict, when multiple leaders try to operate on same data item. Then how that conflict is resolved, that is handled by this module. We're gonna cover that up later, not in this episode. So let me suppose that I have one phone as well, right? One phone as well, which has its own local storage. Very similar, it has its own conflict resolution module, right? And it has a calendar app installed. Now, my ID is signed in uh, all the 3 devices, right? I have my ID signed in. So what can happen is that suppose this suppose my phone is not connected to internet, right? So there is some, so suppose I have switched off the data on my phone and it is currently not connected to internet, but still what I did is that I went ahead on my phone and I updated, or I created an event, right? I created an event on my Google Calendar. So suppose I said that, okay, anyways, if I'm offline, still I'm gonna create a calendar event on my Google Calendar from 8 p.m. to 9 p.m. to have a stand-up, right? Have a stand-up call. Okay, we have a stand-up call from 8 to 9 p.m. That event is added to the calendar app. So the moment we added this event to calendar app, the calendar app, since it is not connected to the internet, it for temporary purpose it stored this event in its local storage. But the calendar app is continuously waiting to come online, and once it goes online, the calendar app will should be sending the data to the server so that all the rest of the devices gets synced, right? So now suppose what happened is that after some time I switched on the data, and now it is no longer disconnected, it is connected to the internet. Now this device is connected to the internet, and in that case what will happen is that the calendar app will gonna create this event, or will gonna, okay, I think something happened with the, okay, uh, never mind. So the calendar app will create this event, and it will gonna create this event, and it will let other devices know that, hey, this event has been created in the calendar and you should also show it. So this, in that case, this event will gonna be available to all the calendar apps present in rest of my devices, may be it in laptop or in a tab. So this once this goes online, the calendar app will notify the servers, and the server will notify other devices that, hey, an event has been added, and you should also add this event in your respective calendar apps, or like the UI, or in the application, so that user can see on their devices, respective devices as well. So this is very similar to what we discussed in a multi-leader replication scheme. The difference being that each and every device is acting as a leader on their own, right? Each and every device is capable of performing a write request. You can do the similar thing on laptop, or you can do the similar thing on tab as well, and that will follow the same approach. If you will add an event on a tab or a laptop, and if they are offline, they're gonna keep it in their local storage, but once they are online, they will gonna write this to the server and make this event available to rest of the other devices where you have your ID has been logged in on the calendar application. So this is one of the use case of multi-leader application scheme. Now let's quickly discuss use case 3. So this will be the third use case of multi-leader replication scheme. Here we will talk about collaborative editing in Google Docs. What it means is that you must have worked on Google Docs, right? And Google Docs provide a feature where multiple user can edit a single document, and that is called collaborative editing. Okay. Collaborative editing. Collaborative editing in Google Docs, or any like document app which requires multiple user to perform editing on the same document. So again, as we discussed in a very similar way we discussed previously, suppose we have two devices, right? Suppose we have two machines. Suppose one is my uh, home laptop, and another is on my office laptop, or suppose like another is a different laptop with a different user on it. So suppose this is a user 1 and this is user 2, have another laptop. They have the another, like similarly, the this laptop will have their own local storage, right? Will they have their own conflict resolution module, right? We discussed earlier as well in brief. Conflict resolution module, they have their own local storage, and they have their own version of document. Suppose doc1, they have the same doc is opened here as well, right? So now what is currently happening is that we have two users on their respective machines, and they have opened a same Google Doc. Say that the name of the doc is Google Doc is doc1. So they have opened the same doc, right? So same Google Doc on their respective machines, and they are trying to perform the edit. Now the thing is that when this user performs any edit or any write on this doc, then again, if this is not connected to the internet, the data will be stored in the local storage. But once it goes online, this change in the doc will be sent to the server, right, the Google Docs server, and this change will be updated, and it will be updated to any other copy of the doc, or basically any other machine who has opened the same doc. So if there is any update, this will be enforced to other documents or other machines as well which has opened the same document. Again, this is very similar to the multi-leader application scheme, because every machine is acting as a leader, because every machine is capable of writing the doc, right? But the bigger problem is the conflict resolution issue, as we discussed previously in brief as well. I'll not cover this in deep, but What is conflict resolution is that suppose both the user tries to edit some at some point of the doc, or basically both the users are trying to edit a particular piece on the doc, then which edit should stay and which edit should be discarded by the system. That this process is basically called conflict resolution process. So the system has to resolve the conflict and has to accept one of the edits, or the machine can do is that they can allow the user to accept this, resolve the conflict. So the machine, what machine can do is that machine can tell the user that, hey, currently I have this two version of this data item, v1 and v2. Now it is your responsibility to accept one of the versions, and then I'll accept this and I'll discard rest of the version. So if the user accepts v2, then v1 will automatically be discarded. So there are multiple ways, there are multiple conflict resolution ways where a machine can resolve conflict. One of the way is taking the help of the user. Another way, which is a bit slow, that is they can have a lock on a particular doc. So what this means is that when a user is trying to edit this doc, they have a lock on top of it. So basically what they did is that they locked this doc, and by locking means that if any other user wants to perform an edit on this doc, then they will simply not be able to, because this the lock has been acquired by any other user. And once the user has edited this doc, then the lock will be released and the rest of the user will be able to, or one of the other user will be able to edit it. But this is not friendly, and neither the Google Doc uses this kind of mechanism, because this is very similar to the synchronous replication scheme, that at one time only one user is, or only one leader is able to perform the edit, and this should not happen. So this was one of the like solution which is not very user friendly. We'll discuss this conflict resolution process and schemes in a very detailed manner in one of our editions. That was it in the multi-leader replication scheme. This lecture was a introductory lecture where we covered multi-leader replication processes, and we also discussed the use cases as well. In the next episode, we will be covering the right conflicts, or this conflict resolution scheme, which we touched upon in this episode very briefly. We're gonna cover this in detail in the next episode. So yeah, I hope you guys like this episode, like this video. So if you liked it, do like it, right? Subscribe to the channel, it would really help. And if you think any of your peers would be like would need help, or this content would be helpful to them, do share it with them as well. And yeah, we'll meet in the next episode.